So we're going to finish section 1.8 today. Yesterday we talked about the quadratic formula. We actually found the quadratic formula by completing the square. Today we're going to talk about a part of the quadratic formula. Notice it's this part right here. It's under the square root. This is called the discriminant. So don't take the square root of it, but just consider b squared minus 4ac. You might have noticed yesterday as we were going through that depending on the sign of your answer, you could kind of tell what kind of answer you had. So the first one, b squared minus 4ac, is greater than 0. So when you have a positive number as your discriminant, a positive number under that square root, the types of solutions you get is two real solutions. And if you consider the graph of this, sorry, I drew this graph ahead of time. I'm just going to copy and paste it. This is where the parabola will run through the graph and hit the x-intercept twice, right? So you have two x-intercepts right here and right here. That's what it means to have a positive discriminant. Then if you remember our third example yesterday, I think it was our third one, when you have b squared minus 4ac equal to 0, when you have a 0 under that square root, this 0, this means that you have one real solution. So in the example yesterday, I believe we got 3 over 5. If you remember that parabola, the picture of that parabola, it was just a parabola that sat right on the x-axis. So it didn't cross it, it just sits on it, it touches it one time. So this has one x-intercept. And then maybe you guessed it, but if b squared minus 4ac is less than 0, so if it's negative, that means that you have two imaginary solutions. So this is where you had that complex number, you had an I that you had to pull out. And this graph never actually crossed the x-axis, right? So maybe it did something like that, just kind of hovers above it. So you have no x-intercepts. So you should be able to go both ways with this. You should be able to see a discriminant and describe the graph. And you should also be able to describe the graph and, see the graph and describe the discriminant. So example 2 here, we're going to use the discriminant. I'm really sorry, I have the wrong heading in this bar. So you can just erase that. What we're going to do here is we're going to just use the discriminant. Use the discriminant. Sorry about that. So what we're going to do is we're going to find the discriminant, and once we found it, we're going to describe our solution. So this is like what you're going to do on your homework practice for today. So again, you have to, just like yesterday, you have to make sure it is in standard form. So we have x squared minus 8x plus 17 equals 0. This is in standard form, so I can name my a as 1, my b is negative 8, and my c is 17. Now, unlike yesterday with the quadratic formula, we're just going to plug it into the b squared minus 4ac part. You're not going to plug it into a square root or anything like that, just this. So when you plug it in, it would be, negative 8 squared minus 4 times 1 times 17. So negative 8 squared is a positive 64. Minus 4 times 17 is 68. So this is negative 4. So we have a negative discriminant. So on Go Formative, how you would answer this, so you'd write the discriminant first, so negative 4, semicolon, and then describe your solution. So if it's negative, that means it's two imaginary solutions. And this is how I want you to write your answers. So this is the discriminant and our description of solutions. Pretty easy to use. So if we look at B, remember this needs to be in standard form. This is not in standard form. It's not in order, and we don't have a 0 on the right. So I'm going to subtract 6 and add 7x to both sides. And then I'm going to rearrange. I need to put this negative 5x squared first. So I have negative 5x squared plus 10x minus 5. So my a here, equals 0. My a is negative 5. My b is 10. My c is negative 5. So then I can use the discriminant and just plug these in. So I have 10 squared minus 4 times negative 5 times another negative 5. So this would be 100 minus 4 times 5 is 20 times another negative 100, and it's negative because it's 3 negatives. So this is equal to 0. Since this is equal to 0, our discriminant is 0, and this means that we have one real solution. All right, part C. Again, I'm going to subtract 5 both sides so that this is in standard form. So I have 7x squared minus 2x minus 5 equals 0. Use my discriminant here. So I have negative 2 is my b. Oops, I guess I should label my a, b, and c, huh? A is 7, b is negative 2, c is negative 5. So I have negative 2 squared minus 4 times 7 times negative 5. So this would be 4. This is going to be a plus, and then 4 times 7 times 5 would be 140. So this is equal to 144. So then my discriminant is 144, and the description of it is 2 real solutions because it's positive. So that's how we're going to use our discriminant. It's pretty straightforward. Let's look at one last part here. So applying this, we have this scenario where a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to the height of 3 feet. How long is the ball in the air? So first of all, we need a height model. This is given to us. It's right here. This h equals negative 16t squared plus v naught t plus h naught. So remember, anytime you have that sub-zero, I always call it naught, but it's just your initial something. So in this case, v naught is our initial velocity, and h naught is our initial height. So we can plug these in then, and they gave us some of these. They say that the ball leaves the juggler's hand 4 feet above the ground, has an initial vertical velocity, and I guess I should say I just put velocity, but we're talking about vertical velocity, 40 feet per second. Juggler catches the ball when it falls back to the height of 3 feet. So what do I know here? I know my h, that's 3 feet. My initial height is 4 feet. And then my vertical velocity is 40 feet. So I can fill in these values. So initial velocity is 40, initial height is 4, and my final height is 3. So obviously I'm looking for my t, and that's what it asks for. It asks for how long is the ball in the air. So I'm just going to take my equation, I'm going to plug in what I know. So we said that our height is 3. then we said that this is equal to negative 16 t squared plus, now my v naught we said was 40 t plus my h naught, which in this case was 4. All right, so once we have these plugged in, we can write it in standard form. So standard form, we just have, I would subtract 3 from both sides. So I have 0 equals negative 16t squared plus 40t plus 1. All right, now I'm using the quadratic formula because I want to solve for t. So as a reminder now, my t will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I plug this in, I should label my parts. We have that a is equal to negative 16, b is equal to 40, and c is equal to 1. So I plug this in, I'll have t equals negative 40 plus or minus the square root of, it'll be positive 40 squared minus 4 times negative 16 times 1 all over 2 times 1. When I simplify this, I'll have t equals negative 40 plus or minus the square root of 40 squared would be 1600 minus, no, it'd be a plus then because negative 4 and 16, which would be 64 all over 2. So t equals negative 40 plus or minus the square root of 1664 over 2. Okay, 1664 probably simplifies, but remember when we're talking about, oh, I plugged in the wrong thing for my a here. I don't have you guys in the room to correct me. Whoops. Sorry, fix this. I plugged in a 1 for my a, but remember the a is actually negative 16. Sorry about that. So this should be negative 32 on the bottom. Okay, so remember when you're working with the story problem, it's better to actually have a decimal answer. That's totally fine only for a story problem because, again, it doesn't make sense. I have no sense of how many seconds that is written in this way, so it makes more sense to write it as a decimal. So if you just type this all into your calculator, what you're going to see is that you get t equal to, so you'd type it in negative 40 plus the square root of 1664 over negative 32, and negative 40 minus the square root of 1664 over 32. So you're going to get that t is approximately negative 0.025, or t is approximately 2.5. You want to throw one of these away because one of them doesn't make sense, and that would be the negative one because you can't have a negative time. So that means that the ball was in the air for about 2.5 seconds. So that's our final answer here. I didn't really leave myself any room, so let's put it up here. The ball is in the air for about 2.5 seconds. So you have a problem on your Go formative that looks like this. I believe I just asked for the seconds rounded to the hundredths place, so you don't have to say anything about the ball. Just say however many seconds it was. Remember, if you have any questions, shoot me a message, and I'll check those tonight.